Okay, my friends, so definitely make sure you're on the perfect linear data tab for starters. We'll get to these other ones as well as we go through the lab. But the first thing we want to do is we want to make a scatter plot. So just go through the steps again. When you've got a nice 2x2 table like this with the labels at the top, input value, output value, you just simply left click and select all of it, just like that. And then you're going to go up to Insert, and then you're going to go to Chart. Now, Sheets is going to try to guess what kind of chart you want. And I haven't quite figured out how it decides that. It gave us what's called a line chart. We actually want a scatter plot, or it calls it a scatter chart, I guess. So that's what you just, I changed that over here. Okay, so now if you take a look at the chart you've got, and I can actually make it a little bit bigger if you want, fill the screen more. There you go. If you look at those points, it sure looks like they lie on a straight line. And that's exactly why I called it perfect linear data, because they are perfectly linear. This is the kind of data you don't actually see out in the real world. But I wanted to start with this because I want to show you how to do a couple things in Sheets that you can apply to any data set, not just perfect linear data. So what I'm going to do right now is I'm going to click back on the chart. Oops, there we go. I guess I have to double click it. There we go. And then you get the chart editor menu off here to the right side. I'm going to go over to Customize, and then I'm going to scroll down until I see the Series option. Now, in that Series option, there's a lot of stuff you can do, and you can mess around with these if you want. The one I want to look at right now is the trend line. And there's a lot of options down here as well under trend line. Linear is fine because this is actually linear data, so that's the perfect choice. You can change the line color if you want. We can make it red so it pops on the points a little bit more. Opacity and thickness is up to you. You can choose that. As far as the label, what I want you to do is actually use the equation. That's perfect. Use the equation. Don't click this show R squared thing. That's a statistical thing that is misused more than it's used correctly. So we're gonna start with that. Okay, so that's how you get a best fit line or a trend line on a scatter plot. And you'll notice that that line goes perfectly through each of the points. Now let's figure out why. It goes perfectly through each of the points because the points themselves I selected to lie on a perfect line. So the equation of this line, it shows it right there. It shows the right-hand side of it right there, 4 times x plus 3. The actual equation is y equals 4x plus 3. Now I want to break down each piece of this equation for you so you know what each piece means. Starting with the left, the y is simply the output value generated by the equation. So if you were to stick an x value in, x is the input value. I guess I'm lying to you a little bit. I jumped over to x now. X would be the number that you put into the equation, and y is the output value you get out. So let's actually just look at the first point on the in the chart over there. The input value is 1, the output value is 7. Okay, so why? Well, if you take a 1 and you stick it in for the x, you then have 4 times 1 plus 3. Now, order of operations says you do 4 times 1 first. So 4 times 1 is 4, plus 3 is 7. Beautiful. Pick a different point. Let's jump down to the 523 point. Plug in 5 for x. You get 4 times 5, that's 20, plus 3 is 23. There you go. That makes perfect sense. Makes absolute perfect sense as to why those input values, those x's, are generating those output values. And you can check more of them if you want. Now, what are the 4 and the 3 representing? Well, the 4, you might remember this from earlier talk that we had in the class. The 4 stands for the slope of the line. The slope of the line. All that tells us is as the output value goes up by 4, the input value goes up by 1. That should make perfect sense, I believe. If you look at the output values, I've actually put them in such a way that they do go up by 4. 7 up to 11 is up 4. 11 up 15 is up 4. 15 up 19 is up 4. Input values, 1 up 2 is up 1. 2 up 3 is up 1. So as output values go up by 4, input values go up by 1. Now you may have noticed that I skipped 6 down here. I skipped an input value of 6. The slope is still going to be 4 because if you go from 23 to 31, that's a jump of 8, and 5 to 7 is a jump of 2. 8 over 2 as a ratio is exactly the same thing as 4 over 1 because it's a ratio. Now, if it's bugging you that the 6 is not there, we can do a little cool thing here. We can highlight the 731, and then we can insert a row above it. And then if you're feeling saucy, you can type 6 here, and then you can type the predicted 27 right there. And you'll notice that that point showed up right on the line where it was supposed to be. Now, that might have been kind of cool. I inserted a row and then added some more points. You can also do that. You don't have to add them in order like that. Like, let's practice it again. I'm going to do a little, I'm going to insert a row. You can add them above or below. I'll add it above. I'm going to add a weird point. Like, I'm going to add 5.32. Now, that's pretty ugly compared to the other nice numbers. But watch this. We can actually use sheets to code the output value. So you can check this out. Equals 4 times that number plus 3. And when you press enter, you'll notice that point popped onto the graph right there, right where it should be at 5.32. Wasn't that rad? As a matter of fact, you could have done up here, I typed in 7, but you could easily have typed in 4 times that number plus 3. You still get 7 because obviously 7 is the correct response if the slope is 4 and the last number is 3. We haven't talked about that last number yet. We will in a second. I'm going to add one more. I'll put it below this time just because I'm feeling saucy. And let's put in, like, I don't know, 4.002 or something like that. And let's practice that coding. 4 times that number plus 3, and then watch that scatter plot when I press enter. It's so close you can't see it. It did show up, but it's maybe that 4.002 is a little bit too close to 4. You know what I'm going to do? Let's make it 4.6, and then watch this. When I press enter, then the y value, the output variable, updates automatically, and you can actually see it on the graph. So that's actually pretty cool. Okay. Let's talk about the last number in the equation, the 3 in the y equals 4x plus 3. Okay, that 3 is technically, algebraically called the y-intercept. Now, what it really is it's the output value when the input value is 0. So, for example, if I insert another row here, and I type an input value of 0, and I do equals 4 times that number plus 3, I'm going to get an output of 3 because anything times 0 is 0. Graphically, it's the vertical location of this point right here. It's going to be the place where it crosses the y-axis. That's why it's called the y-intercept. Now, it's not super important in most cases to pay too much attention to a y-intercept. Especially when you start getting into the other tabs, the not so perfect and the Math 105 data. But algebraically, you will often see that plus or minus some number off the right side of the equation. And that's all it's telling you. If the input value is 0, then the output value is going to be whatever that y-intercept is. Now, one last thing before I end this video. Remember when I typed the code for this one here? If you're feeling really saucy, you can actually drag that formula down and let go. Whoops, I went too far. Let me back it up here. Now, none of those numbers are going to change because they're all correct. But now if you look in the cells, that formula has been replicated. Now, check this out. One last thing after I just showed you how to drag that formula down. If I were to continue this chart, 8, 9, 10, you'll notice that Sheets is keeping up with it. It actually is adding in those other numbers down here. If I drag the formula down further, it actually picks up and continues that formula on these new inputs. Now, these new inputs are not quite as pretty as the old inputs because they don't have the same color. I forget which color I even used. That's pretty close. And then this is going to bug me now, and I have to center it, and I have to make it bold, and I have to increase the font. I'm very sorry. This is where I get annoying with this kind of stuff. I want it to look the same as everything else. Sorry, I'm the way I am. There, that's close enough. It's not perfect, but it's close enough. See, it's not perfect. I got to change it to 12. Okay, now I'm going to stop. I'm not even sure that's right. But it's closer. Just some cool Sheets stuff you can do with formulas, which is really cool. It saves you from having to type in numbers. Okay, let's have you move on to the next part of the lab with the not so perfect linear data.